Hi everyone, and welcome to this Kahal NeuroKit course on visual reactive programming. We are really excited to have so many people from around the world join us to learn Bonsai, and we have put together some great course materials to help you get the most out of the course. The main reference for the materials is the website, neurogears.org/vrp-2022, and also the Discord server that you should have received the link to, where our wonderful TAs and your colleagues are coming together to work for the materials and worksheets, join discussions about Bonsai, and in general have a great time while learning and going through this course. The course schedule is on the website and covers all the days of live sessions from Tuesday to next Monday. We shifted the entire course by 1 day to give everybody, independent of time zone, a chance to catch up to these lectures and get ready for working with everybody through the hands-on worksheets in the afternoon. They run every day from 1 to 5 p.m. and there are 4 days of materials and 1 day of final projects. We will cover Introduction to Bonsai on this lecture and the first worksheet, and then move on to in detail how to design real-time closed loop experiments, real-time markerless pose tracking, data synchronization, and various types of feedback conditions you can set up. And then continue on to designing operant behavior tasks, conditions, state transitions, external inputs, timeouts, conditional logic, and some advice for how to scale your experiments to more complex workflows. Then on day 4, we discuss interactive visual environments using BonVision and how to put everything together to have closed loop virtual reality experiments, and also when and how to combine real-time and non-real-time logic. We will also include logging of both stimulus and response outcomes in these more complex tasks. The final day is reserved for hackathon and playing with your final projects, but we will also cover a bit in the lecture how to extend Bonsai with scripting and how to deploy and version your experiments and integrate it with your coding environments so you can take advantage of Bonsai in a wider variety of settings. So what is Bonsai? Bonsai is a programming language, but it is a little bit different from other languages you might be familiar with, such as Python or MATLAB, in at least a couple of respects. First, it is a visual language, but also the way that you think about putting your program together will feel a little bit different from these other languages where you have to write sequences of instructions to get you from a set of inputs to a set of outputs. And the reason it feels so different is because Bonsai is a special kind of language called an algebra. You know other examples of algebra that you probably use a lot in your analysis or your in the analysis of your data. One very popular one is linear algebra that defines a set of operations that work on matrices, 1, 2, or more matrices, and always give you a matrix as a result. And the special property of an algebra is that it always takes the same kind of input. It's in case of linear algebra, it is always a matrix that you receive and always a matrix that you get out. Another example of an algebra that you might have heard about is a relational database, very popular to represent data in the form of a table, where rows are entries in the database and columns are attributes such as age, weight, etc. For example, an Excel spreadsheet uses tabular format, which is, again, very popular for manipulating data. And the same principles of an algebra applies to a relational database, where you will have a set of operators that take these tables and allows you to combine, join, or filter these tables to get new tables that can represent results of analysis. For example, if you ever use pandas in Python, then it follows this model. And the same as these two algebras, Bonsai is also an algebra that is called reactive programming. And this algebra operates on data streams, on streams of data, but it's exactly the same principle. A stream of data is a sequence of items ordered in time. And again, you can represent, you can define operators that work on such sequences of items and define other sequences of items. And that is exactly what Bonsai provides to you. The other special thing about Bonsai, apart from being an algebra, is that it defines a visual way of combining expressions to define operations over these data streams. To do this, it provides in the package a compiler for the visual language that transforms your workflows into programs that your computer can run. It comes with a development environment where you can put together these expressions visually, and also with a standard library, an ecosystem of packages that you can tap into to extend the set of operations that you can do over data streams. Why do we need a new algebra for neuroscience experiments, and why has Bonsai become so popular in recent years to set up these kinds of experiments? And one of the main reasons, I believe, is the movement from more controlled anesthetized preparations, or even awake head fixed preparations, to closed loop freely moving experiments, where what we try to do is essentially find new ways of manipulating and controlling the signals from the environment to the brain, perceptions, and the changes that animals cause in the environment through action. And these kinds of strategies to retain the ability to interpret our data while letting the animal roam around have been responsible for several revolutions in modern neuroscience on how we study brains in motion. One of the most popular, of course, is place cell research, where experimenters track the animal's position in detail over time and correlate that to the activity of cells in hippocampus. And from those patterns, we can recover that certain cells respond to particular places no matter what the animal is doing. And this was only possible by, first of all, allowing the animal to move around freely in the environment, but also then to be able to track in detail where exactly it is at any moment in time. We have been also, another strategy that has been proved very fruitful is controlling the utility function of the motivation of animals to engage in tasks that disentangle choice. For example, we call it operant conditioning tasks, and the idea here is that the animals, we set up conditions in the environment where certain rules apply, linking perception and action. And in order to maximize reward, animals will optimize their behavior pattern to engage with the rules of the game. So that is really useful, that they can do that even in a freely moving scenario. But again, to do this, we need really precise ways to keep track of what the animal is doing, and to deliver stimulus and feedback to the animal of what the outcome of its actions is. And of course, the final type of such an experiment is one in which we actually design the entire environment to engage with the animal, essentially in real time, controlling, keeping track of where the animal is, and instantaneously responding to the feedback, to its feedback, and that allows us in a way to take control of that relationship completely, and analyze certain kinds of responses, brain responses that cannot be analyzed otherwise. And all of these types of experiments require measuring many things from the animal, not just in terms of neural signals to interpret what is happening in an experiment, but also in terms of just the behavior, understanding the situation that the animal is exposed to. We need to still understand to make sense of these neural signals, what the animal is seeing, what it is hearing, what it is doing, in order to disentangle from the data the possible causes for the behavior of the animal in neural signals. So what we want to do is essentially augment all these different techniques and recordings, styles that have been coming up in the last few decades, with essentially a variety of tasks that highlight certain aspects of animal behavior that we care about. And one thing that has been coming out is that we currently don't have a unique answer to this. We don't have like the one task that will completely resolve our understanding of brain function. So neuroscientists have to come up with a variety of tasks, using a variety of different techniques, different pieces of equipment to be able to set up these situations where we can actually study the brain in its natural conditions. And Bonsai is essentially putting itself in a position where it can help to address. There are certain types of features that are common to these tasks, such as real-time control, real-time tracking of precise tracking of animal behavior, integration with hardware. All these things have been traditionally very task specific and very experiment specific. And one of the goals of Bonsai is to provide a flexible tool to allow us to combine what we have learned from all these different experiments and putting it together to be able to combine these insights from these various different approaches into something more powerful, which is something that has been coming up also a lot. It is essentially that it is not enough to just look at the brain moving in one situation. We want to actually see it move in a variety of scenarios and still have the ways of keeping track of what is going on. So now we've discussed a little bit about what Bonsai is good for, and we can move on to discussing more about how we actually create a Bonsai program. And in Bonsai, the main goal is to have our programs reflect very intuitively what the way we talk about the streams of data in our experiments when we might be in the planning phases. We talk about, oh, in this experiment, I need a camera, a microphone, a recording system. I need a task logic to go through the animal control, the animal trials. And we often draw these diagrams where we connect how which data interacts with each other data, and what exactly operations we need to do to have our experiment running. So Bonsai tries to capture that intuition explicitly in what we call a workflow, which is a structural diagram of how exactly this of data streams and how they connect to each other. So one of the most simple, here is an example of a very simple workflow where we have a source of video, a camera, and another operation downstream, grayscale, that connects to the camera. And what a connection means here is that it's simply that grayscale is receiving notifications every time that a camera is producing a new value. And one thing that is common when people are using Bonsai for the first time is they often think that Bonsai will run in a fixed pipeline, as they might be used to thinking in other languages where you have steps in a program going sequentially and synchronously. And so they will think that, oh, so I get a frame from the camera, then I go for grayscale, and then if I connect more operations here, it'll go in sequence like that. But that's not the case for Bonsai. We really cannot tell that much about how the program is wired up just by looking at the static picture. We need to keep in mind also another picture that is embedded in the workflow, that is the dynamic behavior of each operator that I will introduce now. So this other view is called a marble diagram, and as I was explaining, it describes the behavior of each operation. In this case, the grayscale. So grayscale, in order to understand it, we see that it's connected to the camera. And so it starts with a picture of what the camera is doing. So we have this timeline here, represented time is the arrow. And then each of these shapes that we call marbles, what it represents is a frame coming from the camera. And essentially, it comes periodically. We assume the camera is sampling from the video feed continuously. And then grayscale is going to take each of these frames and convert them into a grayscale frame, and in that way define a result sequence that it basically will have a frame for every single image captured by the camera. It will have the grayscale version of that frame. So a few things that are here that are crucial to understanding the behavior of marble described in marble diagrams. One is what the marbles represent. So in this case they are frames, both raw frames from the camera, color camera, and grayscale frames, but they're also essentially notifications that give us a signal, basically that signal that a new value has been produced. That's very important in Bonsai, because essentially in every operation in Bonsai is reacting, which is hence the name reactive programming for our algebra, is reacting to notifications of new values coming from the upstream operators. Each operator is doing exactly that, deciding what to do when a new value is available. And the way that these values are propagated is through these, what we call them, the on next notifications. So that's an on next. The other bit of notation that is already apparent here is this vertical bar that in the case of a camera is really not usually not present unless the camera stops grabbing frames by itself. But it's essentially a vertical bar that signals the end of a sequence. So sequences can be either finite or infinite. And if they're finite, the end of the sequence will be marked by a special message called onCompleted that essentially tells the operator, downstream operators, that the sequence is ended. And finally, there's another piece of detail that is usually missed in discussions of workflows, which is what happens to initialize this whole process. So how does grayscale tell the camera that the camera should start, or how does the workflow know that the camera should start? Who tells that information to who? And one thing that is most easy to miss from looking at a workflow diagram like this is that actually the initialization of the operators begins from downstream. So essentially, the program starts with grayscale subscribe. So there's an action of subscribing. We are interested in the results of grayscale, and in order for grayscale to produce its results, it needs to subscribe. That's what the connection means. It needs to listen to the camera, and that action is called a subscribe action. That is the action that actually starts the camera running and producing frames. So we can basically get from here that there's actually two flows in the data. So all the connections go from left to right in Bonsai, and essentially data flows from left to right, so from the camera to the grayscale. But actually, subscribe actions start from right to left. So when you first hit play on Bonsai, you will start the grayscale operator going, and then as part of that initialization, it needs to subscribe to the camera, and so that action goes in the opposite direction for initialization. So the other thing we can take from marble diagrams is we can find patterns in the way that certain operators work, and those patterns have been digested for the last few years that we've been working with Bonsai, and been distilled in kind of little helps, little tips of how you can read Bonsai workflows faster. So one of those little hints is the color of the node. So you might have noticed that this node is colored in green, and this node operator is colored in blue. So what do these colors mean? So for example, the blue operators always have a marble diagram that looks like this. We call them transforms. And what a transform does is essentially always react to notifications from the upstream operator by applying some function on the value that arrives, and then emitting that new value as a notification on the output sequence. So basically what happens here is that you know that if 6 frames came through the camera, you'll have 6 frames coming out of grayscale. Because it is a transform, no data will be dropped, and no new data will be introduced. And the operator will respond as fast as possible to the emission of the source value. So it's essentially a just direct mapping from values in the source sequence to values in the new sequence. So whenever you see a blue operator, you know that it'll behave like this. Okay, so this was a very simple workflow to understand, and hopefully it gives you a good feel for what workflows, how to think about workflows. But now we can look at a slightly more complex example. This is a workflow that we use for many years because it kind of captures a lot of the different types of operators that are in Bonsai. And what I want to highlight here is now that we have this operator in the middle, sample, that receives 2 inputs. It now is connected to 2 other data streams. On one hand, it's connected to grayscale, so it's getting notifications from those gray images that we looked at before. And also now it's getting input from a key down source. So a key down source essentially now generates notifications only when a key is pressed in the keyboard. And this can be happening independently of the grabbing of the frames. So frames can be coming through periodically, and at any moment I can decide, oh, I'm going to press a key. And if I do that, key down is going to generate the notification. And sample now receives those two sequences and has to produce a result sequence. This is another important detail, by the way, is that operators always have only one output sequence. No matter what they do, the output is always only one, but they might receive more than one input. So in this case, what sample is doing is best understood by looking at the marble diagram. And now it is a little bit more complex, but we should still be able to follow it. So we start with our grayscale sequence with the frames coming periodically as before, and now we add this key down sequence where we represent hypothetical times where the key was pressed in between the frames arriving. And now we look at sample that is receiving both of those notifications, and we can decode its behavior. So essentially, we see, oh, what sample is really doing is the top sequence is the source sequence, and the second sequence is the sampler. And essentially, what is happening is every time I press key and key down, I'm taking the latest value of the grayscale sequence and sending that as the result in the sequence coming out of sample. So first I got the first frame, I then received the key, sent that frame, then I got another frame, then another frame, and once I press the key, what I get out is this inverted triangle, and the diamond here in the second position was completely ignored. And then this continues until the end. And actually we see a little detail of sample that is important, which is if the sampler sequence terminates, if it completes, then actually sample takes one last value if it is available from the source sequence and sends that out before itself terminating. So this is an important details that can be understood by looking at the marble diagrams, and which is why they're really important to help us read what is going on in these workflows. And now these final node in the sequence in this workflow is save image. So what it does is very simple, but worth going through. This node is part of a category of nodes that are always colored purple that we call sinks. And sinks have basically the special property that they change nothing about the input sequence. So the sequence that comes in is always the same sequence that comes out. So the main difference between what is it that the sink does in that case? So a sink essentially creates an effect, a side effect of processing of the data that we care about. For example, the most common one is sending data out of Bonsai. So what you can probably imagine from the way the node is named is that for every frame that goes through the save image, it goes out the other end, but in the middle here, it gets saved to disk. And the advantage of this is that you can always continue the chain after. So you could add other operations after save image, and they would work just the same, and because of this property. And in fact, you could move save image also to be either after between camera capture and grayscale, or between grayscale and sample, and you could save. So in this case, we are saving only the sequence of the sampled frames. So we're saving each frame for which we press the key. But you could as easily put it after grayscale or after camera capture, in which case we would save all the frames that are coming from the camera. And this without changing anything about save image, because save image doesn't really care about where the frames come from. It only cares about that it will have to save the images as soon as they arrive. So those operators that work like this, that don't change the sequence at all, but only introduce an effect, then they are called sinks, and they'll be colored in this purple color. Okay, let's see a few examples of the workflow editor running to get a feel for how this all works. When you open Bonsai for the first time, you will see these three main panels: the toolbox, the workflow, and properties. So the toolbox is where usually the action starts. Is where you can find all the operations that are available in Bonsai, and you can think of them as the little Lego pieces that you can use to put together your program. You will assemble that structure in the workflow, specifying which operations connect to each other, and then in the properties, you will get to change the values of parameters that control how the behavior of each node actually works. And so to reproduce what we, once you're familiar with the names of each operation, you can directly search in the search bar here. But for now, let's use the toolbox tree to actually find them. So this organization is by category that follows the patterns we were just seeing in the workflow before. So sources are nodes that can be placed by themselves. They generate data without any input. For example, such as a camera or a microphone or a data acquisition system. Transforms are nodes that are operations that are like grayscale. So they just take values from the upstream operation and directly convert them into something else, like in this case, grayscale in the camera, but it could also be finding colors, extracting locations of objects, as long as they work directly, applying thresholds, as long as they work directly on the input data and generate another output data for each element, then they will be colored blue, and they will be under the transform category. Sinks are basically nodes that can send data outside of Bonsai, or they don't change the sequence at all. They just introduce an effect. Can be saving data, can be sending values over the network, can be triggering, using the values to trigger, set the state of a hardware line. Anything that will cause an effect outside of Bonsai, but does not change the logic and the order or the timing or the number of elements in the sequence or the type of the elements in the sequence in any way. It will just, the sequence will be preserved. So that those are sinks. Combinators are like samples, so they can take multiple inputs. They can change the control flow of the program. They can remove elements from the sequences. They can add elements to the sequences. There's all kinds of things we will look in later days on how to use combinators. But they're all stored in here. Workflow and subject we'll cover in later days. So for now, in the interest of time, we'll just skip them. So let's try to find our camera capture source. So here you see, after I open source, there's all these sub categories in here. They represent the packages that you have installed in your environment. The camera capture is actually under the vision package. So we can go there, find camera capture, and literally just drag it onto the workflow. And the node will be placed that represents that camera capture. And actually, just like that, our program is ready to run. So now we can start the program, and the camera is already running. You won't see anything right away, but you can actually, another very nice feature of Bonsai, the editor, is you can always look at what is coming out of any given node at any time by basically right-clicking on the node and looking at its visualizer. So we have a few different visualizers. We'll start with the image visualizer. So here I have another camera, which is what is being grabbed by this node here. And so you can see the frames coming in as they arrive. We can change the visualization type. So for example, here we can go to Object Text Visualizer, and now we'll get a different representation of the data that is just a text representation of the image that tells us a few properties of what are in those, the size of the image and the type of each pixel. So we know there's a 3 channels or color image, 640 by 480. So you can switch between different representations that are available. So now we can apply our transform, our grayscale transform. So again, it's on the vision package. We can find through grayscale here. And again, we can just drag it on the workflow, and the operation will be placed. Now, if we start the workflow, and we go to grayscale. So instead of going for show visualizer every time, a more practical way of going and looking at the data from a node is just double clicking or hitting enter. And if I do that, if I double click, I will get the window to show up with the default visualizer, and we can see that the images are indeed being converted to grayscale. So now we will add our second source that we then want to combine with the sample. So we add our key down. So the key down is on a Windows input package, key down. And now instead of dragging to the workflow here, what we can do is we can also right click, and it can reveal a lot of things that are that can be done with the operator that we selected. And we see here that if we wanted to just place the operator, we could just do it directly from here. So either by clicking on the right click on the context menu, or just by hitting enter. So now our key down is here. So when we do this, we can now look at key down. and differently from what was happening with the camera, when we have key down here, this node will not send values until we press a key. So now I actually have to press a key in my keyboard to actually produce values in the sequence. So now for sample. So if we know the name of the operator we want, we can just type it also directly here. So I can just go and type sample, and this will search for all the sample operators that all the operators with sample in the name that are available in the toolbox. And sometimes there can be more than one operator with the same name, and the reason is that the operation can actually have the same name but mean a different thing. So, for example, sample from the package numerics distributions refers to sampling a value from a random distribution. So taking a sample in that sense. Whereas sample in the reactive sense is sampling a value from a time series. So the name is exactly the same, but you can distinguish in them by thinking about the package and reading the documentation here. By the way, if you have questions about what operators do, now in Bonsai 2.7, you can actually just right-click on the node and click on View Help, and that will bring you to the documentation if it exists. So this one didn't exist, so that's the message you get if it doesn't exist. But for those that we have documented, you can click on View Help, and it might take a little bit, but it should bring you to the help page for that operator. So you can see the description and also the marble diagram for that node. Okay. So sample. So we want to use reactive sample. So sample requires two inputs. So how do we specify the two inputs to sample here? Well, the easiest way is actually to just select them beforehand here. So we say, I want to connect sample to both the grayscale and the key down. So I select it like that. I place sample, and the two inputs that I've selected will be connected to sample right away, and the node will work like that. So if I now start my workflow, I look at sample. So now I noticed that the output type. So one thing, the same way that we can right click on the toolbox nodes to learn more about them, we can also right click on the nodes we place here to learn more about our program. So if I right click on sample, I will see that the output of the node is now an image, which is the source sequence that is coming first through the sample. Then we also can view the help of the node, go to the definition, and so on. But we see now is that even though sample is a sequence of images, nothing is coming through. Okay, and this makes sense given what we saw at the behavior of sample. Nothing's coming through because sample is waiting for a notification from the key down in order to select an image, to sample an image from the series of frames. So now again, I'm going to press a key, space, and you see that when I do that, the last image to be collected was taken. Press again. Okay. So to conclude, the last node we can place here is save image. Now I can just type it in here, and we can actually just hit enter, and it will be placed in the workflow. And now we can actually use the properties to specify where we want the images to be saved. So I will save these under let's say image.jpg. And what we can do is, if we just type a single name, we will always be writing over the same image. So if we don't want to do that, we need to add the suffix. The save image has this behavior where you can specify an automatically generated suffix for the images. So, for example, you can add a timestamp, and what the operator will do in that case is every time there's a new image to save, it checks the current time and takes and adds it to the name of the image. So now if we save that, if we run that, we will see that the same as sample, save image has no input until I actually press a key. And now I've saved an image, and I can again look at different and if I look at the folder where they're being saved, so if I don't specify any folder name, they'll be saved in the current working directory, which is listed here. So in this case, this is the directory. We can actually open that directory by clicking on Browse Directory. Now here we see our images that have been saved. As with JPEG, the default quality is not great, so we can actually save it in BMP. Now we should have better quality images of our data. Okay, so that was an example of how the Bonsai environment works. And now to finish this first lecture, we will go over the ecosystem of packages that has been growing up around Bonsai to give you a bit of a feeling for what you can use to set up your experiments right now. So being open source itself, Bonsai has attracted a lot of collaborations with other open source groups in neuroscience that have been developing both hardware and software for recording brain signals, measuring behavior, controlling boxes and stimulation hardware, and so on. And some of the most significant ones are represented here. We've been long collaborators with the OpenEFIS data acquisition systems, with HARP, with the new behavior hardware ecosystem. We have been working with the Champalimaud, and then more recently BonVision, Neurophotometrics, UCLA Miniscopes, Deep Lab Cut, Bonsai, which has been created by Nick Gilbiot, one of the TAs that is with us this week. You can ask him all about that. And also more recently on Bonsai 2.7, we have now integrated sleep for multi-animal pose tracking. So this is just to illustrate a little bit the kind of experiments that have been driven by Bonsai. So this was my own very first experiment with Bonsai, looking at animals crossing obstacles and analyzing their behavior in real time and changing the conditions of the environment as they moved through the obstacle course. And then we moved to, in the lab of Adam Kampf, we moved to designing more interactive closed-loop environments, like Laurie's video game assay, where we can design a back projection screen, and we are now mixing a lot of different modalities for both inputs and outputs. So for this assay to work, you need to set up a visual stimulus, that also responds to the real-time tracking of the animal, and then itself, once the conditions are right and the animal touches the light, it also activates the poke hardware to deliver a reward. This is an example of integrating data from a dense silicon probe from the Neuroseeker project, a CMOS probe that can record from around 1400 channels, and they can all be streamed into Bonsai in real time. And very differently still, we've also used Bonsai to analyze data in 3 dimensions in VR and for many other purposes, such as designing interactive environments that we will see in the next few days. But more recently, we've been moving to collaborate with other groups, and one of the recent developments that we are most proud of is integration of Bonsai as the official acquisition platform for the HARP protocol. So this is a family of hardware synchronized acquisition and control devices. You can think of them as much like Arduinos, that they can be used to toggle, collect data from digital or analog lines, and also to set the state of those lines. But the main advantage with these devices, they actually have a way of synchronizing their clocks automatically across devices, and also they will everything that is measured in the device will be time-stamped with the clock of the device, and also every command you send to the device to toggle an LED or to deliver a reward will also itself, every action will also be itself time-stamped with the moment when it was actually performed. Another really nice property of these devices is that they have a really low latency, so you have a 1 millisecond latency each way, and they can be used for various purposes, for triggering cameras, for delivering sound stimulus, deliver stimulation pulses, and so on. And as I was saying, the synchronization protocol that allows these devices to synchronize with each other has a very tiny deviation of around 40 microseconds. So it's really useful even for demanding scenarios like recording EFIS data simultaneous with behavior. HARP is also part of the Onyx next generation open EFIS system. So this is a board that also uses Bonsai as its main acquisition system, and it has really nice features. It integrates. You can look at these links, by the way, for every single. The presentation is online, so if you go through it, you'll be able to navigate these links and learn a lot about these projects. But just quickly, apart from the integrating next generation neuropixel probes and tetrode head stages and UCLA miniscopes in one single EFIS acquisition board, the Onyx team, the OpenEFIS team, has also designed these really nice commutators that can be used together with 3D tracking that is set up in the head stage, can be used to record from freely moving animals for long periods of time in complex arenas. So that's all running for Bonsai as well. Neurophotometrics is a company that designs fiber photometry recording systems, and they've recently also made a decision to move all their acquisition system has always been running in Bonsai, but they've been developing their own custom module to make the interface even easier to use. So and in a way, it's nice because you get the data again directly into Bonsai, and you can manipulate it just as if it was another data stream, and use it in closed loop, or just record it as you want, trigger it. One of the projects that we are also most proud of is BonVision, which is a library package for quickly designing interactive visual environments that we'll be covering in more detail. But essentially, it can do everything from simple 2D psychophysics stimuli to 3D virtual environments. And it further has the ability to easily configure multiple displays that can be surrounding the animal in 3D. And we will be discussing a little bit about how this is done in even a worksheet. Important for closed loop control of behavior is also having different ways of extracting the location of the animal. So of course we can use the simple exercises that you will be going over using computer vision to pick up features, salient features in the animal. But more recently, there's been a move to use machine learning to essentially learn features of interest whenever we can label them from a natural video. And deep lab cut has been, of course, one of the forefront of this these developments, and we've integrated a package to support deep lab cut a few years ago, and that has been really popular. It essentially is very simple to use. It's essentially just a transform that takes an image input in and outputs the reconstructed pose of the animal if it is in view. More recently, there has been more solutions for this coming through. For example, Bonsai, developed by Nick, with a TA at the course, has developed this package for multi-animal zebrafish tracking, and also reconstructing specific features of the tail of this fish as multiple fish move around. This is really nice because for zebrafish, the movements are very, very fast, and you need to sample images at a very high speed. And sometimes even with libraries like Deep Lab Cut, even though they are fine to detect these features in a single frame, but they might not run, even with GPUs, they might not run fast enough for zebrafish. So Nick put together this really nice package for helping with that, and it can be integrated again with all the other tools in Bonsai. More recently, we've also collaborated with the team behind Sleep for doing based on machine learning, multi-animal pose, and identity tracking. So these are networks where you can train them to recognize both the body parts of the animal and the identity of each animal. So you can, in this case, it's an example of two flies, a male and a female, and the network can be trained to learn to recognize each individual animal. And again, this is really useful for social behavior neuroscience and many other scenarios. That these networks can be very flexible. And yeah, the package is available now as of Bonsai 2.7 in this link. And we will have a discussion tomorrow about more about these tracking packages. Okay, and that's the end of our first lecture. I hope it gave you a good overview of what Bonsai can do and some ideas for getting started. And we will, don't worry, if you have many questions, that feel free to drop them on Discord and give us feedback for the next days, and we will try to cover all these many layers of Bonsai in more detail in the coming days. So don't worry, you can take it easy, and see you around in the forums.